Well, good afternoon, YouTube. This is my first live stream, so bear with me. I'm kind of nervous on this. It should be fun and exciting for everybody that eventually joins. And if not, it'll still be up online, uh, waiting for everybody to come in. So, uh, where to start? Well, today I wanted to discuss how to um, improve your SWR. Now, everybody knows about these, the Nano VNAs, and anybody that has watched for any length of time uh, the Smoking Apes website, he has, or his channel, he has these really in-depth how to use these really well, and it's really good for helping to get your antenna really tuned to the frequency you're trying to work, whether it's the HF, VHF, doesn't really matter. This will do it all. And while getting your antenna tuned properly is really, really good, and it does help. It does bring that SWR level down to 1.5, 1.4, to where you don't really need a tuner because a lot of radios will handle that. Today, I wanted to go more in depth since my experience for the last 30 years has been dealing specifically with maintaining and getting cell sites and everything really dialed in to be the best they can be. And a lot of times we'll do like a neg 18 on a line sweep, which is really, really good. I know they've let that slack off a lot lately, but it does help. And one thing I wanted to go through was the different types of test sets you can use. Of course, you have the Nano VNA. This thing is really, really good for what it does, and it's relatively budget friendly. It'll get down into the into your $50 or less range. Something else you can use is the Tiny SA, the Tiny Spectrum Analyzer. What this can do is this can really dial in where your trouble is on your antenna line for the antenna, so you can cut it down. But it'll also troubleshoot. Let me see if I can get it here. Sorry about that. It'll also do your coax, and you'll want to test this before you hook it up to the antenna. So one thing you do is you just using a pre-made. It'll tell you whether it actually has any faults in it. But when you go to the spectrum analyzer, what it can tell you is if there's any nicks, cracks, or anything like that. And one thing I've noticed in the 30 years of working with these, very seldom is it the cable. Sometimes it is, and that's because water gets in from the antenna end and it can come all the way down into the connector and cause issues. So sometimes, not always, sometimes it is the cable. These are pretty durable. They really don't get much water incursion into them. But if they get nicked or frayed or whatever, you can get water into them. 99 times out of 100, where we find issues, is with these guys right here, the connectors. Either the connector's not made right, or it's not torqued down properly, or it's something wrong with the connector. Very, very seldom is it the radio. Very seldom is it the feed line. 99 times out of 100, it's the connector. And you can figure that out by using your spectrum analyzer. And one way you can do that is all connectors. Well, most of these they're pretty cheap. They don't do a whole lot, but you can still tell if there's a bad connector because your VSWR will be higher. And when you remake this connector, it could come down. Or, and I don't recommend this because it's kind of outside a lot of people's budgets, and I only have one because of who I work for. You can get one of these bad boys. This is the Anritsu S331E Sitemaster, and it will do what we call distance default. And when you hook this up to your antenna line, it will measure. You have to set the distance default up. You have to tell it your start frequency, your stop frequency, how long the cable run is. So if you're only testing this and you're testing it out to about 50 feet, you want to put it at 0 to 50. That way it only tests out to where your load's at. And it'll tell you where at in the line that there's a problem. Like I said, 99% of the time we find it here. These connectors, doesn't matter what it is, these connectors should always measure at a neg 30 dBm or better, meaning it should be like neg 30, neg 29, or neg 30, 31, 32, whatever. These should always be a neg 30. 25 is acceptable, 30 is perfect. So if you see at 0 feet that you have a neg 4, neg 5, or an open, it's going to be your connector. Either you didn't get it crimped right, you didn't solder the center pin, which I don't solder my center pins on crimp-ons. I probably should. It may improve my SWR. Right now on my knockoff USDX that I have over here, the cable I measured out is from here to the end of the wire antenna I have. I'm measuring about a 1.2, 1.3 to 1 on the entire antenna length. I did not run through the distance default to see where my problem might be, to see if I can bring that down. Could be my antenna, because it is just a 14 gauge wire that I have strung through trees. It could be the QRP guys. I doubt it's the QRP guys QRP antenna that I have. It could be the connector, because I have a PL259 with a bunch of adapters to take it to a BNC, because I didn't have a BNC connector, so I just made adapters to get it to where it needed to be. And as you can see in my shack, I'm doing some renovations. Sorry about that. I still have a lot of work to do. I just got my ham shack back with my YouTube studio, so if it's, if it looks like that, well, hey, that's fine. But you can have that, and like I said, 99 times out of 100, it's going to be this connector right here. Let me see if I can get this. I don't have. I actually don't have anything set up to do this, but I could probably throw this on my spectrum analyzer right quick and try showing you. For some reason, I have a Google Chromebook. For some reason, it didn't go to my external camera, which is why it's all grainy and looking bad. Sorry about that. I tried getting to a 4K camera. It did not want to switch over. Beats me as to why. Whatever. So I am going to get my stuff together here. Now I've already calibrated this, and I want to connect up to this cable and see what I'm reading as far as my spectrum analyzer reads. And luckily I have everything right here where I can just reach into it while we're talking. And sorry this was late notice. I still see I don't have anybody on, but that's fine. I'll broadcast out here to the world. Somebody may or may not join here eventually. We'll see. So what I'm going to do is I've got this all connected up. Maybe here. Trying to connect up to my SO239 at the end of this. One thing you also want to do that a lot of people that have done these, showing you how these things work. One thing they don't show you is whenever you're calibrating, you want to calibrate to whatever you're going to test to. So for example, if I'm going to test this and I've got this SO239 adapter on here, I want to get an PL2 59 male adapter that will go to the SMA female, and I'm going to calibrate to the end of that. Okay, to the end of that. That way, what that does is that takes this connector, this cable, this connector, takes it into account for the line sweep. So I'm going to go in here if I can. I'm going to change my frequencies because right now it's on low. Let me switch it over to low. Since that one's already there, let me switch it there. So doing 50 megahertz as my stop, or starting at 50, stopping. I'm looking at about a. Now let me go ahead and change this because this is actually going to a pre-manufactured 10 meter antenna. So I'm going to do 2800. So I'm going to start at 28.000 megahertz, and I'm going to stop at 29.700. That way I get the whole 10 meter band, since that is a 10 meter antenna. And I am looking at about, let me see, I want to go to measure. I'm going to say my center is 29 megahertz. So with my center at 29 megahertz, I'm getting about a neg 64 dBm. I'm seeing all kinds of signal come in right now. I'm trying to set this back up. All right, so I'm about a neg 106 dBm, which is actually pretty good. So I'm going to do that to slow it down, get a better reading. I'm about a neg 108 at 2800. And then I want to go to mode. Nope, I'm going to leave it right where it's at. I'm going to go to measure linear. There we go. So doing that, I'm looking at about I'm actually looking pretty good. I'm trying to figure out so I'm looking about it's not really giving me there we go. I'm getting about a neg 28 dBc. It's not really giving me my SWR. Let me see if I can figure that out. Reference level auto. Back. I want to go to measure more. Back. Okay, so I'm looking pretty good as far as the 10 meter on the spectrum analyzer. So what I'm going to do is I'm going to move over to my Nano VNA to see what my Hey, I got this side of the radio. Hey, welcome, Shane. Just responded to him right quick. So here I've got my Nano VNA. I know this is kind of a cheap way to do it, hey, but you know, until I can get a way for this to hook up to a Chromebook, uh, or I need to get an actual PC so I can actually hook this up to it so you can see. So this is already set up, but it's not set up for what I need it to be set up for. And I'm losing my mind, but that's all right. I'm going to go stimulus start 28.000 megahertz. And I'm going to stop at 29.700 megahertz. And then I'm going to do my display trace 1 off, back, format. I'm going to do SWR. It's not liking that. Well, there we go. Well, nah, not really. It's not really giving me a good because there we go. I've got a SWR of 10.4. Let me see if I can get that. Yeah, it's kind of hard to show it, but I got an SWR of 10.4. So I probably have a problem with this connector right here. Of course, I also didn't calibrate this since I changed, which you should always do. So if I go ahead and change and go ahead and calibrate here, and see what I get. Let me take a minute and say thanks to Shane. Like I said, this is my first live stream. I'm sure I'll get it better as I go forward. So what I want to do, I want to reach in here to my other adapters. And let me see. This is the one I want. Yes. So I'm going to calibrate to this. So that'll give me all the way through that SO239. Got to grab my open short loads. I'm not going to really do the throughput because I'm not really looking at the throughput. Nope, I don't actually need that. So I'm going to come in here. I'm going to open up my calibration. Nope, I hope I turned it around so I can see. Back, calibrate. All right, so the first thing it wants me to do, put my open on. Let me find my open. I really should tag these so I know. You know, this is what it is, and we'll see how this works out. And you know, if I don't have anybody else join on, that's fine too. Like I said, this will be posted afterwards. Hit my short, go to my load, and then I'll hook back up to that cable and see what my SWR is. Save it as a 1. So that was a 1.0 to 1. So when I disconnect, I jump to an open there. So now what I'm going to do, hook back up to my coax and see what I'm getting. Come on, to my antenna. That's why you should always calibrate. So I recalibrated, and now I'm showing a 1.6 to 1. I don't know if you can see that. Probably not. There we go. I know it's kind of hard to see because my camera's not that great. But anyway, that's a 1.6 to 1. So what happens if I move over to my other antenna that's my end-fed half wave? Well, let's see. Since it's calibrated for, it's calibrated for the 10 meter, so it should give me something for 10 meter. So 10 meters, because this is a 40 to 10. At 10 meters, I'm at a 1.2 to 1, which is really good. So if I change frequency, which really you shouldn't do, but if I leave it at the, and I start, I'm going to go 7.1 75. Since I'm a general class, I can go down that far now. Megahertz. All right, then I'm going to go back. I'm going to do marker 1. I'm going to go to start. Why did my start go to 29.7? 7.175 megahertz. There we go. Now I want to do marker. And then I want to do marker 2 to stop. And then I want to go marker 1 start. No. Reset my so I can move my markers. Four 3 at 21.75, which is in the 15 meter band. Marker 1 at actually, let me do this. Marker 1 at 7.175. I'm at a 1.13 to 1. Marker 2, I move that all the way to 29.7, and I'm at a 1.2 to 1. So I'm actually about a 1.2, depending on which marker I pull. So actually, my wire antenna is really, really good. The problem is, I got a QRP radio, which I know is really difficult to work with, and that's why Ham Radio Crash Course has shirts that say QRP is for heroes. And I have noticed that my radio, when I turn it on, something else that we find is that you don't get these quite tight enough. At work, we have to torque everything down. We have special torque wrenches that'll get down and torque those cables on, and it helps get those. It helps with the reading. It actually improves it. So when I had this on before, I was at about an S4 on all my signals. So let me see. So I'm still at an S4, but that could be because right outside my shack here is our HVAC unit, which will always play havoc. I think I'm only allowed a half-hour live stream. I don't know. I just thought I'd throw this up, let y'all know that, like I said, the biggest problem that we always find, connectors. So make sure you look at your connector. Make sure that it reads good with the spectrum analyzer. You can always tell if there's an issue with it. You might just want to sweep, say that you're not, you can set how far out your sweep is going. Just set it at 0 feet. Let it read it right at 0 feet. And that should tell you if this connector is good. If you're getting a neg 25, I know I said neg 30 earlier. That's because I'm on old standards, but a neg 25 or better will help improve that. So I'm going to go ahead and say 73 is all. And hopefully I can catch more people on the next live stream. And we will catch y'all later.